Hello and welcome to the Dashco Group Development Update. My name is Balaj. We are here with the platform, core, and mobile teams to give you an update of what happened in the past 2 weeks. If you will have any questions and you want to raise that to the dedicated Q&A session at the end of this session, please do so in a way with a Q or question prefix in the live chat below. So I know that it is intended to the Q&A session. We are planning this session for 1 hour, and hopefully we can keep the time. So without further ado, let me find my screen sharing, and we will start right away. Here we go.
Yeah, I just realized it's too bad we didn't do this yesterday on 1st of April. I could have announced, that we're moving into AI or something.
Indeed, we
Uh,
can announce it today as well.
mm,
Would you kick us off with
anyway,
the platform team?
yeah, sure. So me, Igor, and Ivan were working mostly on platform. Lukas was working in TenderDash. Um, Paul continued with the strategies, and GroveDB, Evgeny, and Odysseus. So basically the same as the previous um, review. I mean, what people were working on. So, um, yeah, I would say that let me kind of preface with the main goal for last month for March. We were pushing towards having a version that could not be attackable, right? And that was the goal for the end of the month for when we were done for actually today for the review. Um, and we didn't get there at the end of the month. I mean, we're very close to getting there today. We'll probably have the bill. I mean, we merged in the pull requests that were needed to have that version. We just have to now release it to testnet. We actually have to test it on a DevNet for a day, and then we have to release it to testnet. So we've kind of accomplished that goal. There was a lot of, I would say, very complex work involved to get there. A lot of like small issue mitigation and yeah, so we're going to go through that work. It might not make sense to everybody listening on this call, and I'm sorry for sometimes how technical it's going to get, but I'll try to keep it a little bit light. So one issue that we had for a very long time is what to do about asset lock based transactions. So if you've been following, asset lock transactions are the transactions that bring value from the core chain into the platform chain. Like if you want to add a dash of to platform, you have to create an identity create, and that's uses an asset lock. It's all behind the hood. Users don't actually have to do anything, but under the hood, there's this thing called the asset lock. Now, the problem is it could either be fully spent or not spent at all. And in the case that it's fully spent, well, the identity must be created. They kind of go hand in hand. So uh, let's imagine that there's an error in the SDK. Um, for some reason, not a user-based error, but for some reason, like there was an update and something goes wrong. Well, the user would have wanted to create their identity, maybe with 5 dash. It would say error, and it would have basically taken all that 5 dash and not created the identity. That would have been really, really bad for that user who would have basically lost all their funds. So yeah, so this stuff of mitigating the issues was basically for that. So it would mean that any issue during the creation of would you have to, yeah, I'm just trying to read this. Did I get it all? Yeah, yeah. And if the asset lock was not used, on the other hand, another thing that was possible, then there were attacks on the system because we could do identity creates that had errors on purpose in them, and we just spam those to the system, and there would be like a lot of validation going on, and then nope, okay, well then we don't use anything, and the system just gets hammered. So um, the solution to all of this was quite complicated, but is now done. It's to partially use asset locks, meaning that platform can take the asset lock. Let's say the asset lock has one dash on it, and it can basically use like 0.01% or 0.01 dash of that to do some processing costs, and then say, oh, well, it failed. But hey, if you ever do another identity creation, or you ever want to use this dash for anything else, you can, but I'm taking a small portion of it for now. Yeah, so that was actually quite complicated to do. It's kind of one of those tasks that seem like, oh, well, yeah, why is this important? But until you realize how like important it really is. It's one of without this, yeah, like we would have gotten users, especially in the first few months, who would have just lost a lot of funds. So we have to really worry about those things. And yeah, now it's completed. Okay, moving on to the next thing. Um, in the previous review, there was fixing identity state transitions, part one and part two. And now there's part three. These are just basically a lot of small things that needed to happen to make the state transitions not attackable. They're quite complex, but one is like when I say improve locking when needed to compile a JSON schema and validate a document through the compiled validator. That obviously doesn't speak to many people. If there are people that are technical here, they probably won't even mean much to them. But we're also doing this for people on the call, so that don't really know what like people inside of DCG on the call. Um, so then we did a security level of keys check for document state transitions now happen on validate advanced structure from state validation. Yeah, so there was basically some reordering of the different logics and adding some extra costs here and there to make it so you couldn't attack state transitions. There was a few, especially around document where um like for example, right, basic validation was happening before the nonce validation, and this would cause like somebody to that does like a replay attack to have always the basic validation happen before the nonce gets checked, right? And that's basic validation is not expensive, but it's still not a good idea to have it happen when you're doing a replay attack. So, a lot of things like this to just make the system resilient against attacks. Next one. Um, Yeah, so that was all merged in. Right now, I'm working on processing cost fixes. So what does this mean? There were some things that were supposed to be paid for during state transition validation that we realized just were not being paid for. So these are the five main ones, and I've got three done, and the last two are in progress. Not much work left there, though. Okay, cool. Oh, yes. Oh yeah, that's Ivan. You want to take it up?
Thank you,
Take it up?
Sam. Yeah. Yeah. Hello, everyone. Um, so our
Пап, понюхай, как мое тело пахнет.
excuse me.
Понюхай, как мое тело.
Малыш, я сейчас не могу разговаривать.
Понюхай.
He got attacked.
Слушай,
He got attacked.
Here they're very vicious.
I'm sorry, guys. That's
Your
kid.
son?
yeah, my son Leo. All good. So platform versioning improvements that I was working this sprint. To be honest, it took a while since it's a critical part of the block processing, and it was like many iterations, many fixes, many review sessions with Sam, and the multiple issues fixed. So let's start. The first is not the issue, but it's more like improvement. So we have a block. So platform versioning, what is it? We have a protocol version, which basically this number represents how the network behaves. And when we have some new features or bug fixes that breaks compatibility with the previous data, we introduce a new version, and on a specific block, we switch between the old version and new version. And this upgrade is based on the votes of EVA master nodes in the previous epoch, 2 epochs ago, basically, and based on their latest node software, what they install. So if they have a new version, the node signaling that it has a new version, and if 70%, 75% of the EVA master nodes who participated in this, I don't know, from the total number of EVA master nodes is the signaling the new version, then into epochs, we switching to the new protocol version. And that process was revisited with some improvements and fixes. So the first one is more about the consistency. We have in our block header in platform, we have a consensus protocol version, and it was never updated when we did the protocol upgrade. So together with Lukash, with some fix in TenderDash, some improvement in TenderDash now, proposer, if he's switching to the new version, it's altered the block header with new protocol version, and validators, when they validate this block, this proposal, they make sure that the protocol version is correct. So somewhere in the future, when we want to know like what version we use to process this block, we always know it. There were several inconsistencies how we use the version during the block processing. We have multiple functions that call with the version, and for some functions we use the previous version, for some of them next version, and it's only happening when we do the switch between versions. It's the first block of the new epoch. So now it's consistently using the new protocol version to process the first block of the epoch as well. So now we guarantee that all blocks of the epoch, they are processed with the same version. That mitigate the potential mistakes and problems with that. The next thing is I already mentioned that how we voting for the version, that's the process of the signaling of the new version, and it was a bug when the for the first block of the epoch, we didn't count this vote, so it's fixed. And for the users who are running the nodes, for your master nodes and operators, we added additional information like to output to the logs. So if your node wasn't ready to update, is not ready to update, is not supporting basically next epoch version, you will get the warning in the output of the drive in the logs. And on the switch itself, on upgrade, there will be a verbose panic message with information like how to mitigate this problem. Yeah, and to keep the historical information on the protocol version upgrade, now we store the protocol per each epoch. We have the epoch trees, and that contains the fee pools and other information when the epoch was started, like multiplier for this epoch. And now we added the protocol version as well. So using the epoch info query in SDK, you can query now epoch and see what protocol version was used as well, together with other information we get. Yep, that's it. Thank you.
Or would you
Igor?
continue, please?
Thank you, guys. Hey, everyone. So this week I've been working on a few things. We have some leftovers from the last sprint regarding the queries that are performance intensive, and we had to rework them. Other than that, some convenience methods and some convenience logic in WASM that will allow to generate bindings on the fly. And a spellback and SDK that resulted in generating of the same data contract ID. So yeah, the first thing was about error handling in DAPI, which uses WASM. And basically, right now, for every new error introduced to DPP, we have to write a separate WASM binding, and basically this is we have a lot of errors and a lot of duplicated bindings for them, a lot of boilerplate. So what I'm currently working on, I'm trying to implement a Rust macro that will do the job for us, and we will feed an error instance from DPP to this macro, and it will produce a binding for us. So yeah, this task is in progress. But with the same data contract ID it was caused by using the same nonce for parallel contract ID creation calls. It's actually already fixed and sent for review. And the last thing is adding a data contract history query to RSSDK is still in progress. We actually set this thing aside and worked on it with the less priority. And also one thing I forgot to add to this slide is about the get identities keys query, which we are going to use for DashPay. We need to limit. So basically, this query comes instead of get identities query, and get identities was fetching all keys within every identity, which could potentially halt the system, let's put it this way, if there were too many keys. So yeah, we have to make this query a bit more restrictive so that it won't be a bottleneck. Yeah, this is also currently in progress. So yep, this is it from my side. Thank you.
Thank you very much. Shall we move forward, Paul, and the strategy test?
Okay, yeah. So I last 2 weeks I integrated load tests into strategy tests. So Lukash and Sam, I believe it was them two, basically were using load tests to like see kind of like stress test platform and see how many transactions per second it could handle. Meanwhile, strategy tests, well, the load tests like basically just register a bunch of contracts at the start and identities at the start, and then just like submit a ton of documents. And they want to see how many documents they could submit per second. So I like added that functionality into stress tests, so we can now execute state transitions on a per second basis rather than per block. Before on per block, well, we couldn't like really get a per second transactions per second rate because it's just not how it worked. Like we were in strategy tests, we kind of like submit a transition and wait to get a response from the chain to see if it was submitted and processed. So yeah, I integrated load tests into strategy tests, but um, that means you can do a lot more than just document submissions. You can do every state transition that platform allows in like a per second basis. So that'll be very useful in determining, well,
That's cool.
determining, yeah, how many transactions per second will break potentially platform, and it'll be useful for future upgrades as well.
No break. No break.
Yeah, I actually haven't been able to break anything yet because, yeah, I mean the nonce checker thing is has it sets a lot of limitations on how many state transitions you can do, and that brings me to the next bullet point. I in strategies before was just using one identity to do all the state transitions. So now I upgraded it so that all of the identities that you insert are used to create to the other state transitions. And that helped to avoid these nonce limitations. But yeah, I mean, uh, so what's next? I refactored asset lock proofs and strategy tests. Uh, Asset lock proofs before were super slow, so it was hard to do identity creates and top ups. But yeah, it's faster now. It was so I put done with a question mark because the past couple of days I had it working like pretty well. Like I was able to do 400 asset lock proofs in 15 minutes, while before it was taking like 3 hours at least to do 400. Um, but then today it's working slow. So I don't know if there was some change in core or something, but uh, yeah. So I don't know. I don't know what that is. And still 15 minutes for 400 is too slow. So like next I'm going to make that process multi-threaded because right now it's single-threaded. So that will speed things up. And also I added in the platform TUI terminal user interface, I added like functionality so that you can split the wallet UTXOs into more UTXOs, which is necessary for creating more identity create transitions, basically. Uh, yeah, the faster asset lock proofs made these well made it faster, but if you want to do more asset lock proofs, you need more UTXOs. So that's kind of what I'm working on now. It's working, uh, but it's really buggy. So I'm trying to sort out those bugs.
Very cool, Paul. Yeah. I mean, I can't wait to bombard and platform with the like errored identity creates to see the new. Sorry. Somebody called me. Yeah, sorry. Can't wait to see the work and like the work that we've all been working on, like stopping attacks. So should be great.
Yeah. Thank
Thank you very
everyone.
much. Shall we move forward with Odi?
Yeah. So hello guys. I have been working on GroveDB state sync feature. A brief explanation on what it is and why it was decided to get this done. So the motivation comes for the concept of when a new Evo nodes is joining, we need to have a quick way to reach the same data as all the rest of the Evo nodes of the network. So this is what we call state sync. Otherwise, node is required to reprocess every platform block and until the last one. And I was told that this is extremely slow. So this is something that we really want to avoid by directly synchronizing up to the up-to-date data status. So this is the first one for what I called synchronization from scratch. There is also the other case where an Evo node is stalled or stopped for whatever reason, and we need to resume. This is what I call partial sync. So there will be a concept of, state diff and application of only the difference compared to the sync from scratch. So I guess you already heard that GroveDB is simply a tree of trees internally. And the synchronization of a GroveDB consists of, first of all, synchronization of each tree, which makes sense. And I will explain how we can synchronize a separate tree. And then you can imagine applying the same logic on all trees in order to achieve the global data synchronization. So the concept of the idea is to split an existing tree into subtrees of maximum height of 3. We are calling those subtrees chunks. What is interesting here is the fact that chunks are subtrees, so there are also trees, okay? So we can access to the root hash of those subtrees, and this can allow us to spot easily the difference between an existing database sync, an existing database state, and the one we are planning to synchronize to. And this will help us, basically apply less data synchronization, because this will happen, of course, on the network. So we just want to optimize this feature. And this chunk, apart from the root hash, it includes also some very basic operations that allows us to rebuild exactly the same subtree, which consists of a sort of pseudocode like for example, that operates on a stack, like push this data node, then pop it and make it the parent of the next elements of the stack. So try to imagine this as a pseudo code, sort of. And so, and also another property that we can take into consideration. So chunks on the same level can be processed in parallel. And by processed, I mean generated, transmitted over the network, and processed when restoring the internal state. So we can achieve a sort of parallelism with this property. Can we go to the next slide, please? So this is a very basic example, just to, I know that you already saw examples of GroveDB in the past. I'm just bringing back again a very basic example. So we have the root on the top, and we have some the key main, which is one subtree, which consists of 3 subtrees, for example. And on the other hand, on the same level of with key main, we will have, for example, an empty tree. This is also possible. And so if you go to the next slide, please, we can see, for example, the internal state of the key int and the key int ref and the sum, for example. And so you'll see here that the state sync will consist of beginning from the top, trying to sync every subtree, and every subtree will try to split this subtree into chunks and produce a simple chunk stream and transmit to the network to the new EVA node. So now I'm gonna share my screen, and I'm gonna present a very very basic example of state sync, which of course will take place locally. We're not yet in the level of synchronization between 2 EVA nodes. So this is run locally on my machine, of course, without Tender Dash platform. It's only on GroveDB level. So in this small example, we have like 2 GroveDB databases, the db.0, which is populated with, for example, the same subtrees as I presented into the slides. So with the subtree int.0 with some integers, then on another tree some references pointing to the integers, some tree, and an empty subtree. So in the beginning, we'll see that please ignore all the warnings. We'll see that the original GroveDB has a root hash with some valid hash, and the other one is empty. So we didn't do any replication yet. So now we'll trigger the next step, which is the actual replication. So you'll see here that it iterates every subtree from root to the top, to the bottom, sorry, and it replicates the data. And we'll see that the result of this is the same root hash for the target database. We could think that, hey, if we simply, copy only the root hash, maybe it contains indeed the same root hash, but maybe not all the data. So I'm gonna prove that this is not the case, since we're gonna what is the best way to prove that the actual data are present. We're gonna query both databases on a particular path. For example, I'm gonna query the subtree containing all the integers. I mean, all the integers, the range that I populated in the first place. And I'm gonna query, give me the element with key 2, value 2. And then I'm gonna verify the proof of the return query on both databases. So if we do this, we'll see that querying of the original got this element back, the same on the replicated to, and we are getting the same root hash for the query proof, which is matching with the root hash of the databases. So far, so good. So now we know that syncing from scratch is working. Now we're gonna go a bit on the case of the partial sync. So if we go here, now we're gonna, so after the replication, we're gonna insert one new integer on the original database on the level key int. And we're gonna see all this bunch of data. I will explain what it is. So here, this is on the original database. So I'm gonna paste it here. So here it's basically the state of all subtrees. So the empty one means root. And we see that on the level that we inserted the new integer, we see all the generated chunks with the corresponding root hash. And we see that what differs between the two databases is the root hash of the target subtree and two chunks below. Of course, if we go from this subtree to the top, we'll see that the upper level root hashes are, of course, also changing. So we see here that in order to sync from the left one to the right one, we only need to send 3 chunks of the corresponding subtrees in order to synchronize to the latest state. So currently, I'm working on this scenario, and here, if we do the last step of the demo, we're gonna see that indeed here it says the state diff. So we need to synchronize from the bottom to the top those chunks. Of course, this is the simple scenario, meaning a very small database, but simple in also in the case of the diff. I just added a new element on the tree. We need to cover more cases. For example, if we remove most of the elements of the original subtree, then the number of chunks will be much less. So we need to figure out what is the best strategy to follow. Is it better to empty the subtree and replicate entirely a subtree? So this depends on the number of changes between the two states of the subtrees. I hope that this was as simple as I could, and you guys got an idea on what the state sync is. So I will continue this work until the next presentation, and we'll have maybe more stuff to show. Thanks for watching.
I have a question.
Yes.
This is awesome. What is left?
Sorry?
What
What is
is
left?
Yeah.
The partials sync. So now we determine the, you know, the specific chunks to apply. So I have some errors to fix on applying only specific chunks. So this is one thing I need to finish. The second one is what I said. I need to test with deletes, lots of deletes. So in this case, maybe I need to sync entirely a subtree, empty it, and then sync it. And then the main implementation is done. We need to see with TenderDash and Lukash how to trigger it and how to get the chunk stream that GroveDB generates, and maybe you know, get it into batches and set them to the other node. So
So, but did I understand correctly that from nothing to something is done?
yes,
I mean, okay.
yeah.
So
I
actually,
yes.
so actually, what we could do, right, is, I mean, what we really probably need for mainnet release is state sync, probably, because for people not aware of why this is important, I think it's been said a few times, and maybe it was even just said earlier on this call, but I would like to remind what happens if a lot of time goes by and you want to sync platform, you have to replay all the blocks that existed, right? And that actually takes a long time, much longer than it takes when you're, for example, syncing a masternode, like a core for the core chain. Now, state sync basically makes this a lot faster. But you know, at the beginning, it's completely fine that we go from, you know, only 0 to the full thing, right? Without the partial.
Yes, because the partial, it's a bit tricky. It depends on the nature of the changes and how many changes you have.
Yeah.
I'm not sure even TenderDash state sync protocol supports partial syncing, to be honest.
That's a good news for me.
Yeah, I think so. Like, I haven't been completely following everything you were doing. So for people watching, Odysseus took over work that was done by a previous contributor, and he's been doing a great job. And I think he was working on that more as a for the future, not for the first release. So I think you've done what's needed to get done for now. Congratulations, Odysseus.
Thanks.
Stop
Yay.
working. Stop it.
No. I mean, like, this is great news. This is awesome news, actually. So I think we can for mainnet, for the first, for V1 at least, let's get GroveDB in a state that just make sure it works 100% for just a 0 to the thing to any space, and let's update platform to support it, and then we're golden.
Yeah, sounds good. I'm gonna stop sharing. Yeah. Then we need to, like, when this is done, we need to see like stuff like what is the most optimal batch size for chunks when sending, you know, make experiments and see what is the most optimal.
Yeah, I
So
mean, yeah. So let's start working on that, because let's I mean, it was amazing. The partial thing, but let's just have the partial thing in V2.
Yeah, sure.
Okay,
Cool.
cool. Excellent. Before we go on to the core team, I do want to say kind of where we're at, like give like just a picture. I had forgotten to make a slide for it. As was said earlier, we have the goal for last month was to get a version that couldn't really be attacked. And yeah, we're going to release that this week. We're going to start inviting people to in the community to attack it for the upcoming month for April. In the meantime, we're going to be working on two last things that need to happen. And one of them is the masternode voting and the fees, and maybe a few small other things that are not that are not part of the system resilience. Okay, well, thank you. Let's go on to the core team.
So, should we first?
Alrighty, sound good. Yeah, go ahead and hop over to the next slide. So, we're really just moving forward with version 21 development. There's most of the same stuff that I've been talking about. However, there's one big development that I do want to mention that I'm really happy about. Constantine did some great work in these past couple of weeks and spent a long time trying to figure out the RPC work depth queue issue that we see sometimes. It turned out to basically be a very rare deadlock. This isn't super surprising, but Constantine was able to basically use GDB and dump all of the threads that were running on a couple of systems and compare all of those threads and ended up finding this rare deadlock. This is something that people have experienced on mainnet and we experience on testnet from time to time. And it's rare, which has made it annoying to debug and figure out what's going on. But we had a couple of systems locally that had this issue, and Constantine was able to do a good job to be able to debug it. So I had deployed that version to a number of nodes on testnet over the weekend to make sure that it didn't introduce any other issues. And so far, all of those nodes on testnet, all of their RPCs are still good. We're not seeing we're not seeing that deadlock anymore. So over about, I guess, almost 70 nodes over the last couple of days, everything looks good. So we merged that in now. So I guess actually I should have marked that as done. We just merged that in today. But we merged that in. So do expect that there will be a version 20.1.1 patch version in the relatively near future. Hopefully sometime this week we'll get that out. And basically that will only include this fix for the RPC work depth queue issue. I know there are a couple of masternodes that had there's at least one masternode owner that had reached out to me, and one of their nodes had gotten banned because of this RPC work depth queue. So definitely good to get it fixed, and we're excited to push that out. But everything else, it's hard to show progress here. But Kitty Whiskers did good progress on both BIP324 stuff and Assume UTXO. There's just a lot of like preparatory work that needs to happen on those, and so it's going to take a while. There's a lot of backports that need to happen, a lot of refactoring in the network stack and everything like that. So, yeah, major thing was the RPC depth queue. Backports are still moving forward. You can see that down there. Version 20 is basically completely done now. Version 21 is very close, and the other versions are making progress. So, yeah, we can move ahead to the next slide, give a brief update on the v20.x status. About 31.5% are on version 20.1, and we'll start tracking 20.1.1 in the near future once we get that pushed. But yeah, good progress. I mean, it's a minor version, so I'm not surprised that it's around 30%, but I mean, I'd like it to be more, but it's fine. I'm happy with that. We can move on to the next slide. And we did have 143 Evo nodes if you're interested in that, but Here's the list of merge PRs in the last 2 weeks. A lot of backports. There's a couple of kind of critical section stuff that we've been working on. We fixed that deadlock. That was 5962. I've also been doing some stuff to avoid using recursive mutexes. For whatever reason, the Bitcoin code base forever had used recursive mutexes, which are a lot slower than a regular mutex, but you can call them multiple times in the same thread. And over time, Bitcoin has been moving away from recursive mutexes, and we've also been moving away from them. So I worked on some of that, and also looked at like lock contention stuff that we didn't merge anything related to that right now, but we have a couple of open PRs about it. But a lot of backports, good progress moving forward with BIP324 and Assume UTXO. So, all right, I think we can move on to mobile.
Great, thanks, Pasa. Yeah, we can go on to the next slide there. So for Android, similar theme as before with the Epics combination of Rust testing. Some more changes to the Coinbase API were completed as well. And some further improvements on CoinJoin. So we're going to have another version get released of DashPay for the alpha testing in the next couple of days. And that's based on some feedback from the alpha testers, as well as just our own testing and plans for improvements. So looking forward to that. If you are interested in participating, you can just send an email to support@dash.org and they can get you the info. Slowly pecking away at the Maya integration as well when we have time, but the priority right now is on CoinJoin and the Rust libraries. Yeah, so that's Android. For iOS, heavy Rust and CoinJoin work. A lot of progress on the Rust libraries, so that's really good to see. And as well as on the testing side, they've made a lot of strides on that front too. What else? We had a couple just kind of maintenance related items for Dash Wallet that had to be taken care of. And yeah, the same Coinbase API changes that we did on Android had to be done on iOS. And then yeah, just a few various new functions for CoinJoin. And I don't recall the exact date, but I think as of the last update, we're still held up at the Apple Store for review. That has been passed or approved and released out. So we will have another release coming up shortly as well. Addressed as many things as we can for the Apple review, so hopefully it'll go smooth. Yeah, that's it for mobile.
Thank you very much. So into the questions. I see 2 questions with a Q or question prefix. The first one is, and some of them are already answered in the chat below, but let's just briefly touch them. First question is, when you are planning to update the roadmap? Time is running. We want to understand the deadline period. Thanks all.
Yeah, I think that was answered in the chat, but yeah, I mean, the roadmap is up to date in the sense of planned features. We haven't gone the extra mile on putting specific dates yet until we get past having a stable release candidate on testnet at the very least. So once we have our mainnet timeline defined better, we can get into some estimates for some of the other future features.
And I do think like we're very close to getting to a point where we can be like, okay, it's going to be released in like a few months, right? But there's still some stuff that just, it's best that we don't give a date yet. But I think that after this round where we give out platform to the community and we see the resilience of platform after like a lot of tests by a lot of people, I think if we're satisfied by that and platform doesn't go down, then we can basically give a date because that will mean that yeah, that will mean that there's just not much work left. And I do think that that's going to be the case. I think that we are going to release, and I don't think it will go down. I mean, it might go down, but I don't think it will go down because of attacks. But we'll see. It's one of those things that theory can only go so far. We have to put it in real practice right now.
Right. And the next question, yeah. Do you have any information about Evo nodes on the crowd node? Is it being common nodes in staking dash?
We don't know.
Yeah, it's not.
I don't know.
I think it's best to ask crowd node, though. As far as I know, there's a possibility to.
What I do know is that they have Evo nodes right now. So I'm going to guess that they're going to use they're going to have Evo nodes up right now. Okay, so in the current version of Core, you can put 4000 dash towards an Evo node, and it basically is a temporary measure. Right now, I believe that there's something like 145 Evo nodes on the network. They just have an activated platform. So the platform code is not running on them. And when Core flips the switch, I mean, basically it's not Core that flips the switch. The network basically is going to vote to flip the switch when platform's ready. And then at that point, well, they have to be running the code to generate those rewards for platform. Yeah, so I would assume that CrowdNode would update because they've already shown their intent to do that. Currently, with 145 Evo nodes, the rewards for Evo nodes is much higher than that of masternodes. So there's actually M&O Watch does a good analysis of the rewards between the two. We do here though believe that within a few months they will get closer because a lot of people will switch to Evo nodes for the additional rewards and fee generation, hopefully.
Right. We have a third question, which is credit withdrawal something that we will be added to the platform tutorials?
Yes, for sure. We'll also probably be building a very small command line tool to withdraw. I'm sure it will also be included in popular apps like DMT, and credit withdrawals are pretty easy. You just send the platform a message saying, "Hey, I'd like to withdraw to this address." But for an average user, it's very hard to do right now.
Mm-hmm.
But yeah, we'll make that.
Yeah. So thanks everybody for joining, for the questions and the feedbacks. I hope you enjoyed that, and see you in 2 weeks. Thank you. Bye-bye.
Thank you.